Today we're covering section 1.4, and this is on where we begin talking about complex numbers. If you remember from Algebra 2, complex numbers are expressions that have the form a plus bi, where a and b are real numbers, and I squared is equal to -1. This is where we get into the idea of taking the square root of negative numbers, and this is how we deal with it, is with this I. The real part of this complex number is a, just that value a, whatever it is, and the imaginary part is just the b. It doesn't include the I, it's just, the I just tells you where the imaginary part is. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. And that's just going to help us with solving equations and things like that. So looking at some of these, we're supposed to identify the real and imaginary parts of these complex numbers. If we look at A, we can see the real part is 3. And then the imaginary part is the stuff in front of the I, and that is the -6. So we see the real part is 3, and the imaginary part is -6. For part B, again, the real part, 3/4. The imaginary part is the stuff in front of the 8, or sorry, the stuff in front of the I, and in this case that is a +8. Now part C is a little bit different. Notice it doesn't look like there is a real part. Well, there actually is a real part. It's 0. So we've got 0 for the real part, and then our imaginary part again is the stuff in front of the I, so that's a -2. Part D, this just looks, with 17 there's no I, but again, we can think of this when we're dealing with complex numbers. The real part is 17 in this case, and the imaginary part will be 0. So the A value or the B value, either one of those can be 0 when we talk about complex numbers. If the B value is 0, then we just call that a real number. If the A value is 0, we actually call that a pure imaginary number. So a number that has a real part of 0, the A value, that's called a pure imaginary number. So operations with complex numbers, the nice thing is these work very easily. We basically can treat the I like it's a variable when we talk about these, and that's how we'll do our adding and subtracting. So if we look at this, if we have a plus bi, and then we're adding a different complex number, c plus di, notice we add the real parts together, a and c, and then we add the complex parts together, the b and the d, and then the I just stays there, just like if we were adding two numbers that had an x on them. The same thing works for subtraction. I'll be honest though, what I will typically do is I will tell you to go ahead and distribute the negative through to each of these because people tend to forget that negative. So notice in our answer we have a -c and we also have a -d on the complex part. That looks like a sad face. Alright, multiplication. The nice thing about multiplication is, again, it works just like when we had variables. So we just kind of go through the FOIL process. A times C gives us AC. A times DI gives us ADI. BI times C gives us BCI. And then BI times DI gives us BDI squared. Now, if you remember back to our first statement there, this I squared equals -1. So when we have B times D times -1, that's going to change the sign on that portion, and so that's going to make this minus BD. So this whole thing is going to become a -BD. So now when we add our like terms, we get AC minus BD, that's the real part, and then we can see AD plus BC. Those are the two parts that have the I on them. The key thing is just FOIL it, and then wherever you see an I squared, replace that with a -1. That's really what you have to focus on here. So expressing in the form of a plus bi, we can see these mathematical operations. Notice this is addition. Please don't multiply it just because you see parentheses. So we've got -1 plus 4 gives us 3. And then we've got 6i and -2i. Again, just like terms, we add them together and we get plus 4i. For the second one, again, what I will say to do is go ahead and distribute the negative through this. So now, just to write this below, we've got -4 plus 2i. So -1 and -4 gives us -5. 6i and 2i gives us 8i. So again, subtraction, please make sure you distribute the negative through that parentheses. Too many times people will subtract the 4, but they forget to subtract the second part there. Now part C, this is where I said just go ahead and FOIL this. So we've got -1 times 4 is -4. -1 times -2i is going to be positive 2i. 6i times 4 is going to be plus 24i. And then 6i times -2i is -12i squared. Now remember what I said about I squared? I squared equals -1. So we want to think about this whole thing. -12 times -1 makes this plus 12. So finally we add our like terms. -4 and 12 is 8. And then 2i and 24i gives us 26i. Now part D, you may see that, and that looks a little bit weird. I to the 97th power. What we want to do is kind of take a look. We know that I squared is equal to -1. Well, what that means is that I cubed, we can break that up as I squared times I. So that makes it -1 times I, or -1. That's not right. -I. -I. And then I to the 4th power equals I squared times I squared, which would be -1 times -1, and that is 1. So then if you think about I to the 5th power, here's where we start repeating this pattern. That would be I to the 4th times I, which is 1 times I, and that gives us back to I. So everything from there on, I to the 6th, is going to be the same as I squared. I to the 7th is going to be the same as that, and it just keeps repeating. So the key thing here is this one right here. I to a power that's a multiple of 4 is always going to equal 1. So what we have to do is break up this I to the 97th into a power of 4, a multiple, an exponent that's a power of 4, and 1. So the power of 4 that is closest to 97 and still less than it is I to the 96th. 96 is divisible by 4, and then we have 1i left over. So we have to remember I to the 96th equals, since it's a multiple of 4, it equals 1. And then we have 1 times I, and so our answer for that example is just going to be I. You may want to practice a few of those. We don't do tons of that, but there's probably one of those on your test when we get to that point. So just try a few of those, make sure you kind of understand that concept, that any I to a power that's a multiple of 4 is always going to equal 1. Now, we talked about conjugates with radicals. We also have complex conjugates when we are dealing with imaginary numbers. The complex conjugate complex conjugate of a plus bi is a minus bi. Notice the only difference is this sign right here in front of the imaginary part gets changed. So if your original number was 3 minus 4i, the conjugate would be 3 plus 4i. And this leads us to our final operation of division. When we talk about division, in order to simplify a division problem, which is right here, we take that same fraction, and notice we are multiplying it by the conjugate of the denominator. So we take the conjugate of the bottom part. So notice what we've done. There, it was c plus di, now it's c minus di. We're going to multiply both the top and the bottom by that value. And really the rest of it is just multiplication using the same method we used before where we FOIL this out. One thing I do want to point out, the reason that we can do this, I'm going to have a lot of marks all over this page. The reason we can do this is that fraction, c minus di over c minus di, is equal to 1 because it's something divided by itself. So that's, again, it's kind of like when we get a common denominator, we multiply by 2 over 2. We're able to do that because that's just a form of 1. Let's get rid of this writing before we go on. So that's the key thing, multiply by the conjugate. And what happens is, and again, I wouldn't memorize this, just go ahead and multiply it out the way that we know how to. But the key thing is going to be on the bottom here when we FOIL this. I will show you this. You take c times c is c squared. This gives us minus c di plus c di, and then minus d squared I squared. So two things. The middle terms cancel out, and then here we have negative d squared times negative 1, and that makes this into plus d squared. So that's how you get that c squared plus d squared on the bottom. The middle terms cancel out, and the I squared makes that second piece positive. Again, this right here is not something you need to memorize. I would just work on FOILing it out and using the methods we already know of how to simplify when there's an I squared. So let's go ahead and try these two. The first one, again, we find our denominator. It's right here, and we're going to multiply the top and bottom by 4 plus 2i. And so now we just FOIL. Negative 1 times 4, negative 4. Negative 1 times 2i, negative 2i. 6i times 4, 24i. 6i times 2i is positive 12i squared. And again, what do we know about this? It's equal to negative 1, so this thing becomes minus 12. Because 12 times negative 1 is negative 12. On the bottom, we can FOIL this. We get 16 plus 8i minus 8i minus 4i squared. And again, we already said those two middle terms cancel. And again, because this is negative 1, this whole term becomes plus 4. So for this problem, to simplify the top, we've got negative 4 and negative 12 gives us negative 16. The imaginary parts, plus 22i. And then on the bottom, we've got 16 and 4 is 20. Now, anytime we have an imaginary number, remember we have to break it up so it's in standard form. So we've got negative 16 over 20. That's the real part. We've got 22 over 20 times I. That's the imaginary part. And then anytime we've got fractions, you always want to simplify. So the first part, they're both divisible by 4. So it will become negative 4 over 5. The second part, they're both divisible by 2. It becomes 11 over 10. And so we get negative 4/5 plus 11/10 I for part A. Part B, notice this one is a little bit different. We don't have a binomial in the denominator. So if you just have something with an I in it, it might still be easy. This is 0 plus 3i. So what are we going to multiply by? 0 minus 3i. which really we see that's just negative 3i, top and bottom. So on the top, again, we have to, this time we're just distributing. We get negative 12i plus 6i squared, and again, that's negative 1, so this makes this a minus 6. On the bottom, we have 3i times negative 3i. That gives us negative 9i squared. And again, because this is a negative 1, that makes this just a 9. So, real part first, imaginary part second. We've got negative 6 over 9 minus 12 over 9 times I. These can both reduce by 3. On this first one, we get negative 2 thirds. On the second one, dividing by 3 again, we get negative 4 thirds I. So that gives us our answer for part B. But again, simplify, then you always write it in standard form. A plus B times I. I believe the last main topic we've got for this section is dealing with simplifying. If negative r is negative, if the opposite of r is negative, then the principal root of the opposite of r is the square root of negative r, and what that means is anytime you see this negative, you take it out, and it becomes an I in front of that radical. So with any negative number, what we do is we take out the negative, and it becomes an I in front of the radical. So you can see that's what happens here is now there's an I in front of the radical, and you just have the r inside the radical. The two square roots of negative r, or the opposite of r, are plus or minus I, because we factor that out, times the square root of r. So you still have, when you talk about square roots, you still have two answers, a positive and a negative one. So to evaluate this, we've got this radical symbol. Remember the radical, unless the plus or minus is in front of it, the radical just means the positive one. So with this negative, we take out the I. So we have I square root of 9. And then we know that the square root of 9 is 3. So we have 3 times I for that first part. For the second one, and again, once you do a couple of these, they're pretty clear, but you take out the I, and we have square root of 25. Square root of 25 is 5, so our answer there is 5 times I. So what happens when we see a problem like this? Well, the first thing we want to do is simplify. So even though we haven't talked about it in this section, we can break up this 18 into a 9 and a 2. And then in this one, notice we're going to take out the I. So minus I square root of 2. And then let's go ahead and simplify this. 3 square root of 2 minus I square root of 2. And then here we have the 5 we can't do anything with, plus, take out the I, square root of 9, and that gives us 5 plus 3I, because the square root of 9 is 3. So now we just FOIL this out. First ones give us 15 square root of 2. Remember, we can multiply anything outside of the radical. That's a little bit of stuff from last chapter. This times this. Well, 3 times 3 is 9. And then we have an I, and we have a square root of 2. Just a note here on the i's, when you have a radical, pretty much the only time we put the I in front of a number is if there's a radical in it, because we don't want there to be a question on whether that I is inside the radical or not. And just to show you what I mean, it's very clear that the I is multiplied by square root of 2. When you have this, sometimes it's not clear, does this little line here go above the I, or does it not go above the I? So just to avoid confusion there, we put the I in front of the radical. So then we have this times this, that gives us a negative 5I square root of 2. And then here we have negative 3I squared square root of 2. So again, notice because of this I squared, that equals -1. That's going to change this to be plus 3 square root of 2. So now we can combine our like terms. You've got this one and this one. They have like radicals. We get 18 square root of 2. You have this and this. Notice they're both I square root of 2. And that gives us plus 9 minus 5 is 4 I square root of 2. If you really wanted to get fancy, notice they both have a square root of 2 in that, and we could factor that out. And that would leave 18 plus 4i. I guess I would accept either one there, because again, typically we write things in standard form, which is real part first, imaginary part second, and but again, if they're asking us to factor, there's a lot of things we could do there. So now to solve, if we want to solve an equation that has an x squared like this, we've got, if there's only one x, we just get the x by itself. We subtract 81. And then notice when we take the square root of both sides of this equation, we have to put in the plus or minus. That's the key right there. When you take the square root of both sides of an equation, you have to put in a plus or minus. And then notice we pull out the I, and we have the square root of 81. So then our answer is x equals plus or minus, square root of 81 is 9, and so we get plus or minus 9i. For the second one, that doesn't factor. So we're going to have to go quadratic formula. Just to remind you, x equals negative b plus or minus square root of b squared minus 4ac over 2a. And we will just plug these values in. Notice a is 1, b is 3, c is 9. So x equals negative 3 plus or minus 3 squared minus 4 times 1 times 9 over 2 times 1. That gives us negative 3 plus or minus square root of 9 minus 36 over 2, which is negative 3 plus or minus square root of negative 27 over 2. You can see we've got a negative inside the radical, so that's going to be an I. So negative 3 plus or minus I square root of 27. And remember that we can break up the 27. We have to use a perfect square. And 9 goes into 27. So negative 3 plus or minus I. We can break it up into square root of 9 and square root of 3. So negative 3 plus or minus square root of 9 is 3. So 3i square root of 3. There's a lot of 3's here. And then remember our last step, since this is an imaginary number or a complex number, we want to, because of that I, we want to break it apart. So our final answer, negative 3 halves plus or minus 3 halves, 3 square root of 3 over 2, and then we put our I at the end. Notice in this case there is a radical, but since it's a fraction, we can still put the I at the end without having to worry about if it's inside the radical or not. One thing we do want to note is that our complex solutions, and let me erase some of this so you can see what I'm talking about. Some of our complex solutions, or all of our complex solutions, to a quadratic equation will come in pairs, and those pairs are complex conjugates. So we had the plus or minus 9i, and if you remember the answer for this one, negative 3 halves plus or minus 3 square root of 3 over 2 times I. Well, notice if you just look at the plus, and then you just look at the minus separately, that's two separate answers, and they are conjugates of each other. So our assignment for section 1.4 is page 114. And you've got several groups of problems there to work on. Again, it's usually 15 to 20 problems somewhere in there. But that's your assignment, and please take a look at some of those, and you can ask any questions tomorrow during class.